Everyone. Today I'll be going through this new Discovering Mathematics exercise 9.1. So this is about the chapter arc length, area sector, and then also radian measure. Okay, so let's start off with exercise 9.1, question 6. So let's read the question. So in the diagram, O is the center of the circle and then reflex AOB is 315 degrees and the arc ACB is equal to 24 cm. So A, find the radius of the circle. Okay, so what we can do is we can create, right, the formula of using arc length, right? Because arc length of ACB is given, which is 24, right? So let us, recap lah. So arc length formula, okay, I should use a red. Okay, so arc length formula, okay. So arc length, right? The formula is given by theta over 360 times 2 pi r, right? So in this case, for part A, our arc length is 24, right? Our theta is 315 over 360, right? Times 2 pi r. So r in this case is the unknown that we are finding in part A, which is the radius of the circle. All right, so let us just do a bit of a simple calculation. So we will end up having 7 over 4 pi r equals to 24. So this part here will become 7 over 4 pi. All right, and then how to find r? So r equals to 24 divided by 7 over 4 pi, and that will give us 4.36539, round off 4.37 cm 3SF. Okay, so this is for part A. All right, let's move on to part B in black ink. So the perimeter of the minor sector OAB. So perimeter, so means is this part here, the arc AB, and then add up the two radius. Okay, so very important because perimeter, right? So means perimeter means what? It's like the fence, right? The fence that circle the whole minor sector OAB. All right, so we have to find OAB lah, right? Arc OAB. All right, so how to find arc? Arc AB, right? So how to find arc AB? So arc AB, right, is equals to the theta over 360, right? But our theta is now 360 minus 315, okay, over 360 times 2 pi, and then our r is 4.36539. Okay, and our arc, right, will work out to be 3.42856. Okay, that's our arc. So the perimeter, right, will be just equals to 3.42856 plus 2 times of the radius, right, which is 4.36539. All right, so yeah, that will give us 12.159, right? Round off 3SF, 12.2 cm, right? 3SF. Okay, so yes, this is the perimeter of the minor sector OAB. All right, so this is it for question 6. Okay, let's take a look at question 9 together. Okay, so let's read the question together. So in the diagram, right, O is the center of the circle. Okay, so angle AOB is 50 degrees and the angle COD is 100 degrees. So everything is labeled on the diagram, right? Very clear. So part A, write down the ratio, right? Arc AB, all right, is to arc CD, right? Expressing your answer in the form of 1:k, where k is a constant. So basically, we have to find out what is our arc AB. But what is so weird in this case is that the radius is not given, right? But doesn't matter because we are only required to find, right, the radius. I mean the ratio, sorry. So we do not really need the radius. Okay, so first I'm going to start by saying let question part A. So let R be the radius. Okay, I want to let R be the radius. So if I want to find out arc AB, right, what is it? 50 over 360, correct, times 2 pi r. All right, and this, right, will give me 5 over 18 pi r. Okay, so next part, arc CD, right? Arc CD is 100 over 360 times 2 pi r. Okay, and this will give me 5 over 9 pi r. All right, so the ratio, right, is, so ratio of arc AB is to arc CD. So AB is to CD, right, is 5 over 18 pi r is to 5 over 9 pi r. So, yeah, I better write the r properly. Yeah. So as you can see, right, that means both the things got pi r, right? So we can just cancel them out. Okay. Yeah. And then after that, you just got to key in your calculator. So what you key in is you take 5 over 18 divided by 5 over 9. All right. And then it will give you a ratio of 1. It will give you 1 over 2. All right. So that means it will become 1 is to 2. All right. Yeah. So this is it for part A. So that means our K, right, is a constant and K is 2. Okay. So that's it for part A. All right. Let's move on to part B. The ink, where I'm using the blue ink on the left. So part B. So the radius of the circle is r. Okay, so yeah, so they stated here. They stated it here. Radius of the circle is rcm. Find an expression in terms of pi and r for the sum. Okay, so read carefully. Sum of the lengths of arcs CPB. So CPB is here and AQD. AQD is here. So they want these two blue arcs added up together. But recall, just now we already found what CD and BA, right? So we can say that, so the idea is this, we are going to find the circumference of the whole circle minus away arc AB and minus away arc CD. All right, okay, so let's find out. So first, let's start by finding the circumference. So the circumference of circle, right, will be equals to 2 pi r, right? So 2 pi r, that's it. All right, then arc AB plus arc CD is equals to what? 5 over 18 pi r plus 5 over 9 pi r. So this will give me 15, hold on, 15 over 18 pi r, okay? Then after that, I want to find this, right? So that means I can say that arc CPB plus arc AQD is equals to 2 pi r minus 15 over 18 pi r. All right, so this will give me, let me do a quick calculation. So you'll give me 7 over 6 pi r cm. All right, yeah, so this is the sum of the length of arc CPB and AQD. All right, and this is it for question 9. Do question 10 together. So the diagram shows a sector OAB. So OAB is here, right? It's a sector of a circle with center O. So that means OA and OB is the radius. So P is a point on OA such that OP is 6 and PB is 8. Okay, and then they tell you the angle OPB here, this is 90 degrees. So part A, find the radius of the circle. So the radius of the circle is actually here, right? Or OA. But if you look closer, right, I should use OB. Why? Because there's a right angle triangle here, right, which allows me to use Pythagoras theorem. Okay, so part A. So that means I can say that OB square, right, is equals to 8 square plus 6 square, right? So OB square is equals to 100. Then OB is equals to 10 cm. Okay, so therefore the radius is equals to 10 cm. All right. Okay, so that's for part A. Okay, now let's do part B in red ink. So angle AOB, so they want this angle, right? So what can we do, right? So basically, because triangle OPB is a right angle triangle, we can use Tuakaso. All right. So this is the angle that we want to find. So this is the opposite. This is the adjacent, right? So that means tangent. So tangent angle AOB equals to opposite, which is 8 over adjacent, which is 6. So angle AOB, right? Angle AOB equals to tangent inverse, tangent inverse, right? 8 over 6, which will give us 53.1301. All right, so angle AOB is just 53.1301. All right. I mean, round off to 1 dp, so 53.1 degrees. Okay, Okay, so let's move on to part C. Part C will be in green. So part C, the perimeter of the shaded region. Okay, so very simple. We need to find AP first. Right, AP will be just the radius minus 6 lah. So radius is 10 minus 6, so 4. Okay, so this is 4, this is 8. We need the arc, right? So arc AB, right, is equals to 53.1301 over 360 times 2 pi times R, which is 10. All right, so the arc, right, will give me 9.27295. Okay, so the perimeter, the perimeter, right, is equals to 4 plus 8 plus 9.27295. All right, so yeah, that will give us 21.2729 round off, 21.3 cm 3SF. Okay, so the answer, yeah, the perimeter is just 21.3 cm. Okay, all right, so this is it for question 10. Go through question 11 together. So this is going to be the last question of exercise 9.1. So I will proceed on to exercise 9.2 in a separate video. All right, so let's read the question together. So the diagram shows a sector OAPB of a circle with center O. Then they say that the perimeter of the shaded region APB is 30 cm, right? So this straight line and this arc is 30 cm. And then angle OAB is 60 degrees as labeled here. All right, find the radius of the circle. So as you can see, right, OA and OB is radius, right? Right, and then that means this angle here will also be 60 degrees, right? If this angle here is 60 degrees, that means this is also 60 degrees. Okay, angle AOB, this is also 60 degrees. Therefore, this is actually an equilateral triangle. Lateral triangle. All right, so that means I can say that AB, this line AB, is also the same length as the radius, which is R. Right, so that means I can say this, I can say arc APB, right, plus the radius, right, gives me 30 cm. Okay, so arc APB, how to find? So it's actually 60 over 360 times 2 pi R plus R equals to 30. All right, so 60 over 360 is just 1 over 6, right? So 1 over 6 times 2, so 2 over 6, then 1/3 lah. So 1/3 pi R plus R is equals to 30. So factorize out R, so 1/3 pi plus 1 equals to 30, right? So R is equals to 30 divided by 1/3 pi plus 1. All right, and that will give me, hold on for a minute. Okay, 14.6541, round off 14.7 cm. Okay, so 3SF. Okay, so, please make sure that you know what I'm talking about for this triangle lah. Or basically because, so I can write down in words lah. So OA is equals to OB, right? Because why? Radius. They are the same, right? Okay, so that means since angle OAB is equals to 60 degrees, therefore angle OBA, right, is also equals to 60 degrees. And also angle AOB is also equals to 60 degrees because 180 minus 60 minus 60 also give me 60, right? So this is like base angle, or rather sum of angles in a triangle lah. Right, sum of angles in a triangle. Right, so that's why my angle AOB is 60 degrees. And it also means that OA equals to OB, right? Which is also equals to AB. Because they are equilateral triangle, right? Means all the sides are the same. Okay, so these are the realization that these are the things that you have to get from the information provided in the question. Right, you got to interpret the information and then come out with your own conclusion. This is what they are testing you on. All right. Okay. Yeah. So this is it for question 11.